Okay, I'm assuming you've performed the experiment as per the lab manual, which had sodium hydroxide in the conical flask down here, and the ethanoic acid in the burette. And when you put your indicator into the sodium hydroxide, that is the phenolphthalein indicator, it turned a pink colour. So if we look at what's happening to the pH as you add the ethanoic acid to it, you start off with a very high pH because it's all sodium hydroxide, and as you add it, the pH drops, it drops, until eventually it will drop very rapidly, and then you'll level off again. Now, the reason it's dropping like this, at the equivalence point, the pH is going to be a bit higher than 7, because the products at the end point, or the equivalence point I should say, are going to be sodium ethanoate and water. Now, sodium ethanoate, this thing here is a basic ion, because the ethanoate ion has come from a weak acid and will be readily accepting protons, so it behaves like a base. So overall, your equivalence point is going to be basic side of 7. Now, we chose phenolphthalein as the indicator because it changes colour from between about 8 and 10. That's when the phenolphthalein will change colour. If we chose the methyl orange, we would find that it's where it changes colour is sort of between 5 and 3. So that's going to be changing colour way down here. Now, that would mean you're going to have to add a lot more of the ethanoic acid has to be added to get it down to that colour change there. So when you're doing your calculations, what you will be assuming is you had to add a lot more ethanoic acid to neutralise the sodium hydroxide. So that's what the question is saying. Will your calculated concentration or percentage of the acetic acid be too high or too low? So you have to use that information to see how you can answer that question.